Okay, so we're going to start to look at geometric series right now. And in the top left corner of your screen, you can see the formulae that we're going to need to use. But I can't just give you those formulae because then you won't have earned them. You're going to have to listen to me talk about why they are what they are for the next 5 minutes. So let's start off by thinking about what a formula could be derived from. So the sum, if we're talking about geometric, is going to be that first term plus the second term, which I'm going to write as u1r, plus the third term, which is u1r squared, and so on and so on, right? Okay, now the last term, perhaps the penultimate term would be u1r to the n minus 2, because the last term would be u1r to the n minus 1. And remember, this is the nth term formula for a geometric sequence, right? So it's going to be the last one that we need if we are summing to n terms. So there it is, right? So what I'm going to do now is I'm going to try to think of some clever ways of manipulating this to derive that formula that I want. So I'm going to start off by multiplying by r, right? So if I write the left-hand side as r multiplied by s of n, then all that means is I'm going to have an additional r on every term, okay? It's going to look like this, isn't it? Yeah? And that penultimate term will then be r to the n minus 1. And the last term, most importantly of all, is going to be r to the n, right? And notice, look, it's beginning to look a little bit more like that formula that we have at the top there. Okay, so what's the point of that? Well, we can do some clever things. So imagine we've got, I'm just going to put this piece here in a bracket, look, okay, that bit there in that red bracket. Well, that is almost the same as the top line, isn't it? The value of Sn. In fact, I could write it quite similar to that, because I could write that as S of n. The only difference is it's missing a term, right? It's got like the second term, it's got the third term, it doesn't have the first term. So in a sense, that bracket is the sum of a geometric sequence, but without the u1, okay? And of course, I've still got this term on the end here. We better write that down. That isn't included. So we've got this situation like that. Okay, so from here, well, we don't really need those brackets, but we can move things around and kind of ignore them because we're only adding and subtracting at this point. So I'm going to take Sn to the other side. So I'm going to write Rsn minus an S of n. And that's just going to be equal to, well, that u1r to the n and the minus u1. Now, from here, the whole point of this little trick was to factorize. If I'm looking for a formula that's going to be equal to Sn, then I need one S of n. So I'm going to write Sn, open bracket, r minus 1 on that left-hand side, and u1 r to the n minus u1 on the right-hand side. In fact, you know what? I could even take a factor of u1 out of that right-hand side. Let's do that now. So we're going to have u1, open bracket, r to the n minus 1. Finally, I'm going to divide through by r minus 1 to get Sn equals u1 r to the n minus 1 all over r minus 1. And that is one of our original formulas, all right? Now, there's two of them up the top there. We get the other one just by multiplying top and bottom by minus 1, okay? So if we did do that and multiplied top and bottom by minus 1, it's just keeping it the same. It's just keeping it equal to the same thing, because minus 1 divided by minus 1 is just 1 still. Then another way we could write this is also Sn equal to u1, 1 minus r to the n, all over 1 minus r. It's going to flip the sign around, and that's why we have two equivalent formulas. All right, so in the next video, we'll look at how we use these and give you some examples, but that is where this formula